first example, we have a bag that contains 5 red blocks, 18 yellow blocks, and 10 green blocks. Find the probability of the following. So how many total blocks, how many total outputs are there?
33.
33. I'm going to zoom in on it. Here we go. Alright, so we have 33 total blocks. So I'm just going to kind of write that right here. Okay, so Jose picks a red block on the first draw, then replaces it. Then he picks a green block on the second draw. So by looking at what we're given, is it going to be independent or dependent, Tucker?
It's going to be independent.
Independent. So, but why are you thinking that that's good?
Because it says then replaces it.
Very good. So then replaces, so it's independent. So for the first event, it's the probability of picking a red. So what's the probability of picking a red block?
5 out of 33.
5 out of 33. Very good. Now he picks up that red one, and then he puts it back into the bag. So for our second event, it's going to be the probability of picking a green one. So how many total blocks do we have?
33 over 30.
Right. We still have 33 blocks. And then there's 10 ways that a green could be picked. So, probability of red and
That's 15 over 30.
green is going to be, well, we're going to multiply them together. So is that what you said, Tucker? 50
Yes.
or 15?
15.
Okay,
Then
good.
5 times 10 is 15.
So it's 5 over 33 times 10 over 33. Which ends up being 50 over 1,089.
It's 15 over 9.
Yes. I didn't. I multiplied.
What's that number?
Well, we're multiplying because it's 2 events and we have the and in here.
80?
So that's why we're multiplying them together on this one.
89?
89.
Like simplified.
Well, on this one you can't simplify it at all. That's the most simplified form. So what I did was, okay, so 5 times 10 is 50. 33 times 33 is 1,089. You don't have to. I mean, you could work it out.
So it's like the formula is pretty much saying the possibility of choosing red and then green. So the order matters. Like if I put a red and then green, if I put green and then a red, would it change?
No, because you would still multiply them together. But this could also be, okay, this does work where, say he has the bag and he picks 2 out at one time. What's the probability that is a green and a red? It would work for this one too. Picking them out at the same time would work for this one. Okay. What? Why we didn't add them? Because we're taking 2. So before it was what's the probability that we get one or the other. So we add it. Because you're just picking one, what's the chance that you get this one or this one? But here, we're picking 2. We're picking more than one. So that's why we add it. That's why we multiply. Okay, so for B, Emily picks a red block the first time, then without replacing it, picks a green block. So is this going to be dependent or independent?
Dependent.
Dependent. So what's our keyword here?
Without replacing.
Without replacing it. Very good. So event 1, probability of picking a red is going to be 5 over 33. Very good. So it's just going to be the same as the first one. Now the probability of the second one, so we picked out the red one and we threw it away. So what are the total number of blocks we have left?
4.
32.
Right, we have 32 blocks left. And then how many green? 10. Does everyone understand why we have 32?
Because you took one out and you didn't
We
put
took
it
one
back.
out, Karen, and got rid of it.
Yeah, but up there when you took the green out and then get rid, when you took the green out, how come
Then
that was not
replace it.
there?
We put it back. We put the red one back here.
I know.
But then here, we just took it out, and then that's the end of the experiment.
How come, for the peach green is, if you took out, 10 green blocks, it's not, 23.
No, we're not taking out 10. This is how many, remember probability is